I need to, if you imagine this as a split section horizontally, then currently this mask is something like that. And we need to have something like that, or ideally like this at the end, to have, you know, a smooth brush like this. And we need to calculate the normal out of it like that. Can I do it analytically, like completely analytically, or do I need to take samples and derivatives? Looking at that thing, I have two coordinates, x and y. And I don't know. Let's try the stupid way. So derivatives for now. I make a function that will be called how can I call it? Calc5. And it will take UV. No, float. Float's good. Take UV. And let me replace that thing here. And this I can take to the top, and let's do constant float, constant vac. And calculate height, add the UVs. So mask, float mask equals calc height UV. Does not return the value, return mask. Okay, it's the same. It's the same. And it works. So now HS says so a smooth step. Yeah. So if we have this is a cone like this one, and this could be done with a smooth step. Mask equals smooth step 0, 1 mask. Yeah, much smoother. First, let's disable it for a while to just see if our normal will be correct, and then we will enable this again. So now the normal. Vec3 calc normal back to UV. So it will calculate 3 points. If you look at this from top, this is the center of the cone, and then it will take the main point, then the right 1 unit to the right, and 1 unit to the top. This can be 1 pixel or anything. And then it will compare how big is the height here, for example 0.9, to here, for example 0.8. And then it will know that it goes minus 0.1 in that direction. Okay, so minus 0.1, it will know that the slope is negative in the y direction. It will do the same to the right, and then we'll know what is the slope in the given pixel. Here it should be flat on top, and in the middle also, and here in the cone it should be accordingly curved. So calculate normal, And yeah, float samples equals float and the first sample will be just calc height at the UVs. By the way, let's try if I got the syntax right, because I don't remember how to do an array. Maybe like that. Does not return a value. Return, for now, whatever. Okay, this is the syntax for making an array. So this is origin to the right and to the top. Okay, so this will be UV, and let me add const float it will be normal kernel size equals I don't know, something small for now, whatever, in UV space, or it may be vec2 in UV space. And also aspect ratio could be a constant on the top. Const. So I can already multiply this vector by this. Okay. Legomin asks, if I declare array on the left, why do I have to declare it on the right? Because it's GLSL syntax. In HLSL you can do this, but in GLSL you can't. So, sorry. What does it say? Assigning non-constant to const IP float. Oh, really? Isn't it a... it's uniform float, maybe. Must be constant expressions. Oh my. It is a constant expression. Okay. And now I have to repeat it everywhere because GLSL doesn't allow for uniforms like this. Calc normal does not return a value. Return. Okay. Now let's display this thing. Let's display vec3 normal equals calc normal UV, and the normal will be here. For now, let's return 12 of 1. Beautiful. Jeffrey asks, why kernel? I mean kernel because I just want to, this radius, you know, the size of, or the length, how far to go with this test from the origin to top and to the right. Is it 1 pixel or less? Actually, I think it wouldn't matter in the end, mathematically speaking, but let's see. Height UV. Okay, so back to UVs equals back to, and it will be the same. There is UVs, and first it will be just UV. Then it will be to the right, UV plus back to normal kernel, or just kernel size 0, and then UV plus 0 kernel size, like this. You know, one to the right, one to the top, and the original thing. And then we have UVs 0, UVs 1, UVs 2, just the elements in the array. Okay, so we'll have 3 samples of the height this time. The same that we had, a little to the top and a little to the right. Let's see if that's true. For now, instead of normal, I will just show the samples. So sample 0, samples 1, samples 2. For now, for the test. Too many arguments. Why? Why there are too many arguments? If I have UV, what's wrong? Kernel size. Okay, sorry. Kernel size X, kernel size Y. Syntax error. Great. Now I want to make this kernel size bigger to prove the point. Yeah, you can see that. I'm just showing, you know, this is nothing valid. I'm just showing you what it does in magnification. So it samples the height, it calculates it with an offset. This one is to the top, this one is to the right. And this one's original. So this should be super small to be useful. Like this. And now we'll compare them. So compare this point to that one, this to that one. Okay. So now, float. Difference in X. What? Legomil, why are you saying no? No about what? It destroys formatting. What destroys formatting? Be specific. dx will equal samples 0. No, samples 1 x. No, samples 1 minus samples 0. And float dy will be samples 2 minus samples 0. Cool, I think. And now it's a stupid method, don't repeat it, but just as a test. Vec3 normal will be dx, dy, and 0 normalized. Just for now. Return this. Cool, it's something. At least we have directionality. And as you can see, as I said, it's a cone. Now, should we enable? Okay, but first let's display it as a vec3 normal tangent space will be, or normal pact will be normal times half, I think, plus half. Okay, cool. But something is still off. This blue on the flat should be 1 because it's complementary to the other channels. Or because blue... There was some math for it, right? That normal x and y. Yeah, even if it's normalized. Oh. Okay. Yeah, it shouldn't be 0. It should be anything. Just not 0. Something small, but not 0. Hi, Piatnashkin. Legomi says that his text was destroyed by Twitch formatting. Yeah. Okay. But thanks for the example, sure. And he asks if I would get the same result from polar coordinates. I don't know. Maybe. I was wondering if I could do it fully analytically, but I couldn't come to a conclusion. But yeah, this takes samples, sample on the top, sample on the right, compares it to the origin, and from this it knows the slope. So now this is a cone, and to get this smooth, the blue example, we will do smooth step as suggested by HS. So take a look. Not that good actually. I was hoping for something better. Why is it so bad? It's smoother, sure. But I was expecting at least this, the curve. Maybe the kernel size is too small. Or maybe this is wrong. Oh yeah, this was wrong. This was too sharp. Actually, the blue thing should be derived in a more intelligent manner. Now, smooth step works. It surely does. But I don't like the fact that this is, hard-coded. Like this. It shouldn't be. But in Unreal we have a function for that, so don't worry. Okay, so we have something. By the way, let me save this. Sign in. Let's make a new one. And let's call it normal. Private. At least one tag. Normal. Legomi says that polar coordinates have the same components, so the direction and then the distance from the center. But Legomi, how would you do smooth step? Like, can you try in Houdini to calculate this? I mean, with the direction analytically. Because yeah, this is easy in polar, but I mean this thing, like we have here. If you succeed, then sure, I'll be glad to learn. Okay, we have that. Yeah, I have radius, and sure, you can do the curve on the radius. But I mean, how to get... look at this. If you have this smooth slope, then here you should have 45 degrees, right? But here you have something higher. Here you have something higher again. And on the beginnings, you have upwards. So you know how to do that without sampling. If you can find out, I will get to know. Okay, let's do it in Unreal Engine. So let's go here. Let's open the brush with normal. And we have our render target, we have UVs. Render target. This was brush shape. Okay, so we have brush shape. And here we calculated distance to the UVs. To the UVs. So I would need to repeat these calculations. But does it mean I have to copy this? I don't like the idea of copying. But I think, yeah, I would have to take a sample up. Oh my. This would be ugly. Sorry for this already. So that. But there is remapping of the hardness, yeah. So that. This again. Offset right. And this again. Plus offset up. Oh. Okay. And the texture coordinates are texture coordinates, but I need to add an offset. So this will be what the offset was, like something small. Kernel size 002. Like this. Here was also an offset. Like this. And add. And add. Okay. Distance. To the modified coordinates. And here we have the output. And we will need to compare it. So subtract new right to the old value, new up to the old value, and append that, then append some z, or actually derive normal z like this. And there was also derived normal z function. Because I wonder... Normalize, okay. Let's see what it gives us. So append vector. Oh yeah, there is a normal. Did we use smooth step on this? No, we didn't. Or did we? It was then multiplied by brush flow. Marcus Cross Marcus is now following. Welcome. Welcome, welcome. Have a great time with us here. Okay, so I had my brush previously. This was it. Oh, where's my brush? Wait, start previewing node. Unlit. Here? No. Hold on. There's render target. Ah, because we weren't painting to alpha yet. Okay, whatever. Start previewing node. Yeah, this was it, right? This was painting with the brush. And this is the shape of the brush in the current frame with the given hardness. If we reduce this, of course it's softer. If we do this like 0.9, super sharp. And here is the normal. But actually it's super sharp. Maybe the kernel should be different, like this thing. Kernel size. No, it's too big. Or maybe it should be smaller. No, it shouldn't. But I wonder why is it so extremely sharp? We have the hardness here. Maybe it's again this... No, we have derived normal Z. I wonder if this expects us to do constant bias scale. You know, scale half, bias half. Or something. No, I don't think so. That's weird. That's really sharp compared to what we get. Ah, wait, because we just have a cone. Sorry. So we need to do a smooth step. Smooth step with 0 and 1. Yeah, HS, exactly. Smooth step is missing. So here. Yeah, that's the problem with copying code instead of making a proper material function. That you have to recreate this every time. Value. And once again, yeah, it should be a material function. I was just too lazy. I have a smooth step now, but it's not as smooth as I would expect. It's like this. Is it due to hardness? 0, 0, 1. Yeah, I think it is. Okay, great. We have this. We have a normal. And let's put normal in RGB and the brush itself in alpha. But something's wrong. Something is wrong. And we also have to combine it with the previous render target. So we'll have to multiply this, or no, flatten normal, and flatness will be brush opacity, brush flow, inverted brush flow. So 1 minus x. By the way, brush flow should be clamped to 0 and 1. And yeah, brush flow 1 minus x. And I will use that as a flatness of the normal. So instead of this of the strong one, we'll have this much weaker. But we shouldn't care that it's much weaker, because it will be strong when you draw very, frequent samples. So render target RGB. It should be, yeah, we will need a 32-bit render target unless we would pack the range. So how is it called? Normal blend. Blend angle corrected normals. Base normal will be the old RGB. New normal will be the additional normal. And then let's append it. And then let's put it into emissive. Okay. So yeah, here we calculate the normal, make it weaker from the brush flow setting. Oh, and there is also, actually wait. There should be also a lerp because here is subtracting. It's darkening it over time. Yeah, I shouldn't support it yet. Let's deal with it later. Let's try if it does anything interesting. Here again. Render target snow. Let's just read this RT RGB as the normal. Dynasty is raiding with 66 people. Welcome, welcome. Great to have you here. So what we're doing today is we are failing to do a displacement painted with the brush, because it seems there is no tessellation in this Unreal Engine 5. I don't know why, or maybe I couldn't find it. So I tried to fake the normal first, but it didn't work well. This is Parallax Occlusion Mapping, by the way. By itself it works great, but it doesn't give us lighting information. Oh, so you confirmed that they removed it. So maybe they removed it because, in Nanite it's not supported anyway. And it's an old technique. Or phased it out, yeah. So what we're trying to do is something quite technical, but let's hope it's, the technique itself is clear. We're trying to, let me show this first. Ctrl+V. Take a look. This is our brush. and we're taking one sample to the top and one sample to the right, and look for the difference in each direction to calculate the slope. So to know that this is which side of a cone or a fall off it is. And thanks to this, thanks to these differences, the derivatives, we know the normal, kind of. Tangent space normal, right? Because we assume it's always z up. And I also recommended, because this is Shader Toy, a great website, but I also recommended ShaderAd, ShaderAd.org, if you want to, let me paste that, current shader. So ShaderAd is kind of an offline shader toy. You can write shaders and immediately see the effect on the right. So it makes learning GLSL and HLSL so much easier. And in ShaderAd, you can also stop and analyze the value of a variable. So this is amazing. Even Unreal Engine doesn't provide you that. Okay, so back here. Ilya Cole says that's really cool. It is. ShaderAd is cool. And here, back to Unreal, I recreated that code that I pasted on the chat in Unreal. This is copy pasted. Sorry for this. This is, the origin, right and top. And then I tried to recreate a normal, so derive normal z. Out of 2 directions, I get 3 directions. And then I mix it with the previous normal, with this node. Blend angle, corrected normals. Let's see if it does anything. But first I need to read this. So maybe not as a normal. Let's start with showing it as a base color, and I do it unlit. Okay. Nothing painted yet. And there is nothing. Was anything painted, by the way? In the alpha channel? No. Oh, something is in the blue channel, and green, and red. But it looks like the same thing. Wait, this is RGBA 32-bit float. Sure. The clear color is wrong. It should be black. Okay. But still. And brush material template is wrong. Brush material template should be with normal. Yes. And now. Still nothing. Oh, there's something. There is something, and it looks a little bit like a normal map. So why doesn't it display that? Painting render target, painting normal. Here. Okay. Still nothing. Because it copies the state. Whatever. Let me open the material. Thanks for following. Normal map. It's emissive color. Sorry. Unlit is slightly different. Okay. Here it is. Super bright. Because too much normal has been accumulated in this spot. So let me go back to the brush thing. To the brush thing, yeah. Yes. And normalize the result. So normalize like this. Still super strong. So I may want to make this weaker. There is flow that I flatten with. But instead, I may actually lerp. Or no. Let's do it like this. Let's multiply comp mask. Or no. Make float free. Let's take this brush flow. It is multiplied with what? With the brush itself. But there was also the information whether the brush is active or not. I stored it in blue. 1 if brush is hit any surface, 0 if not. So this is it. So I would want to multiply the brush flow with this information whether it hit anything or not. Multiply with 1 if active, 0 or if brush pressed, brush active, 0 if not. Multiply flow. Okay, here is the flow. Z should be unchanged, so 1. And I multiplied the normal of the brush with this. So whatever normal I have as a result, I multiply it with the flow setting, which is usually something low, like 10%. You know, the opacity of the stroke. And then I should multiply it with a general normal strength multiplier. Normal strength multiplier. Okay. And having this made, I normalize it, or I shouldn't? Oh, maybe not. And put an additional normal here, then normalize. And to emissive color. Let's see. Play again. Yeah, now it only shows up when we're painting. But it's still extremely strong, as you can see. So maybe, where's the brush? Maybe this should be much weaker? I don't know. Why is it so strong? No, it's still extreme. So, back here, I think something may be wrong there, because I subtract, but I don't normalize. How was this code? Legomir says that he may know how to make it analytically without samples and derivatives, but he has to go to work and he can post the code on Discord later. By the way, about the Discord, invite people. Invite people. And chat. Discord. Okay, feel free to join. So here, what we did, samples, then this, and then normalized. Okay, because normalization gives you a unit length vector. So the vector will be always length of 1, just showing you the direction of the original vector. So instead of this derived normal z, we may start with adding something hard-coded and then make float free. Or just append, or no, make float free like this. This has to be any small number and normalize. For now, this would be better, but for now, maybe this will be enough. Let's see. Still very strong. Huh. I normalize that. I wonder if I multiply with the correct value. Wait, there is brush flow. I should just, maybe not even clump it. I should just give the brush flow here. Then I multiply x and y of this. Sure. There's normal strength multiplier. It's wrong. It should be here. It should multiply the flow itself. Like this. And only then, let's just, wait a second. We have brush flow, multiply with the, mask if brush is active, if it's pressed or not. Then multiply with normal strength multiplier, something constant for now. And then it should only multiply x and y. That's why we do it like that. Make float free. And multiply the normal itself. Right. Let's normalize again. I know it's not efficient. It's bad code, but for now. Too many normalizations. Sorry for that. We'll clean it up later. I don't know if it's any better, to be honest. Seems super strong, if you ask me. It doesn't have any soft edge. Like if something here was wrong, maybe this is wrong. Let's try 0, 0, 2. I would like to have some way of previewing it easier. Let's try how one press looks like. Okay, it's too strong already. Let's go back here. Derive normal Z. Normalize. But let's see for now, how does it look like as a normal map? So let's open this render target. This material. Static mesh. And let's just use it, not unlit, but standard. Default lit. Base color will be something bright. And let's just use that as a normal map. Like so. Okay, the effect is super weird. So the normal is definitely wrong. I know why it's wrong. Because the default should be 1, not 0. So let's go back to this render target without alpha. The default should be up, vector up. So X and Y are 0, but Z is 1. Now it should be better. Okay. Yeah, we have something. We have something, right? By the way, the initial goal was to paint it behind the moving character, but I guess we may be out of time because I spent it on trying to make it work. It works, but it's super, super strong, and I wonder why. But as you can see, we have a normal. So at least we have something. Piatnashkin asks, isn't it in word space? Yes, it is, but in this case, word space and tangent space shouldn't matter much. Or maybe they do. Or do they? Maybe they do. Okay. But 1 should be 1 anyway. It shouldn't be that strong. You know, the axis may be flipped, but still it should look similarly. Let me open the material. The snow material. And let's convert it. Because this is tangent normal for sure. Or isn't. There was a setting here. Tangent space normal. Whether the material takes a tangent space or a word space normal as the input. So yeah, let's assume this is tangent space. Yes, you can see the values are extreme. Can I preview the value somehow? Or do I have to use the inspector? Like debug pixel inspector? Start inspecting, come on. Ah, it only inspects the screen. Jeffrey asks if maybe I should try a super small value in the flow. Yeah, maybe. So brush. And let's try. I'm doing way too many normalizations, I think. I'm doing this, then multiplying the strength of X and Y. And then normalizing again. Doesn't it normalize in the end? No, it does not. Where's the snow? Wait a second, where is it? This thing. Yeah, brush. And then I append. But is the flow really working? It should be 0 X and Y. Oh, huh. Yeah, let's try super weak flow. 0, 0, 1. Kind of better, I guess. And now 0, 0, 1. Yeah, Jeffrey, that's a good advice actually. Now it's painting with the right amount of flow. Like this. Probably there's an error in the math somewhere, but yeah, who cares? Okay, it does work. It could be slightly stronger, 002, but that's about it. Okay, fantastic. Now we may try enabling the parallax occlusion mapping back. Let's get rid of that thing. Parallax occlusion mapping. It should read the same painting normal. Okay, but the hive channel is alpha. So 0, 1. Great. And the hive ratio should be negative, I think. It should be flipped actually, but I can't do it here. Let's try. Base color. Texture will be whatever, can be concrete. And then as a base color. Okay. But the hive ratio is way too weak, I think. Let's try 1. -1. Minus. Wait a second. Did I use these UVs? They shouldn't be multiplied. Wait. No, that's wrong. They should be here. Is there some tiling parameter? UVs. So let's do UVs multiplied with tiling, like 8 or 16. And 2 UVs. Let's see. Piatoshkin says, finally we can make the fresh sidewalk vandalism simulator. Yay. It looks wrong. But why? There is base color. There is this texture. Parallax UVs. Hive map texture is here. Because it uses the same UVs. Okay. That's unconnected. That's weird, if you ask me. Hold on a second. Hive map texture, right? Render shadows is false. Light vector, we don't care. Hive map channel. Do we have something in the alpha? We don't? What the hell? We only have something in the red, but no alpha? Wait a second. There's this brush. And brush. Yeah, there's a brush flow. Oh, because the brush flow is now much too weak, I think. Or is it? Can we make it brighter somehow in the preview settings? No, we can't. Because, you know, I want to know if there's any information at all. Because there's brush flow. The vanishing mechanism. I should detach it for now. I should detach that. And yeah, there's this flow multiplied with whether it's active. I should do it here. Yeah. There's brush shape. Cool. Let's delete this vanishing over time. And wait, what was this doing? Lerping with previous frame. I think I don't need that anymore. I just take either previous frame or one, depending on the brush flow combined with brush mask. So that's really good. And yeah, it should go to alpha. By the way, does emissive color support alpha? I think it should, but who knows? Who knows? Or maybe it's just RGB. That would be very bad. Shading model unlit. Okay, let's see. It's still going crazy. So we have something in all channels, but nothing in alpha. Is it possible that... I think it is possible. That emissive color doesn't allow packing to alpha. Oh, that would be so bad. Because then I would need a separate material for normal and for this. So maybe instead... No, I can't pack it in anything. I can pack it. I can pack it in blue. So let's use blue as the height. And let's not export Z. Let's not export Z. Let's append R and G. Derive normal Z. It will be very inefficient code and can be done better, but I don't care right now. Derive Z normal goes instead of this. I will just unpack it from R and G, like so. And then I will only pack component mask R and G. And derive the blue again. Okay. Should be cool. And then in the snow material, I should also how is it? Append R and G, derive normal Z. Emanuela Celli, thank you for following. I hope you have a great time here. Today is quite technical stuff, but usually we do different stuff. By the way, guys, you can watch on techart8.com on my website. You can watch most of the previous streams. So there is less hardcore stuff in there too, like things based on word position, making your own simple tools in Blueprint in Unreal for level design, and making your own tools for everything, like creating new materials or managing files. And I've also shown the recent one was burning wood. That was it. So if you're interested in that kind of stuff, please check it out on techart8.com. This was the previous thing when I showed my own old material from 2018 and how it was made. So yeah, but today we're trying render targets and we're trying dynamic displacement, which doesn't work yet, but it will. Base color, normal. Let's see. Let's see. Oh, and the default color should be different now. We should change it. Where is it? RT painting normal. Clear color should be black again. And alpha won't matter anymore. Okay, let's paint. Play. Yay! So the normal works and it is unpacked. As you can see, we have beautiful displacement. The normal map itself. So now, do we have height in the blue? Yes, we have our brush in the blue. Great. So we can use that as the height information. So let's go back here. The height map channel will be 0, 0, 1 blue. Plane shift, welcome. You guys are raiding me today. That's great. That's really humbling. Because this is a second raid. Previous one was from Dynasty. You're very welcome here. What did you do on the stream today? And how it went? I hope it went well. We're doing dynamic displacement like this. So we have a brush, we're painting, but as Unreal Engine 5 doesn't have tessellation anymore, or is it hidden, then instead we are painting a normal map. Why is it so slow? We are painting a normal map like this. And for that, I created a shader in GLSL that tries to take a black and white brush and calculate a smooth normal out of it dynamically. And then we're painting with this stump, like here. Wait, is it? It's too bright. Okay, cool. So now let's try adding parallax mapping in a second to have some texture. PlaneShift says, I was working on morphing our character into other races. If you have a spell which transforms you into a chicken. Cool. Very cool. I don't remember if original PlaneShift had conversions like this, but I played it in, I think, 2006 or something. PlaneShift was a game of my adolescent years. One learner says your voice sounds like Pablo from Blender. I really recommend Pablo from Blender. He's working on brushes too, actually, sculpt brushes. And he did tremendous improvements to Blender's sculpting. And he's a great artist as well. Very skillful. Okay, so here, let's try parallax. So back to our material. We have just a flat color now. Just a flat color. But here we have parallax occlusion mapping, taking this texture that we paint as the input. Then the blue channel as a height map channel. And the height ratio, we'll have to figure it out. Currently it will be upwards, unfortunately. I will have to invert it somehow, but that's for later. Parallax UVs, sampling base color texture. Let's do something visible, can be cobblestone. And to base color. Okay, cool. But I would like to have some tiling or something. Manual texture size, no. I don't know how to do tiling. Okay, let's try. Right. So it looks very deep, as you can see, because this is all in the shader. There's no displacement. But due to the fact that we have black as the default it thinks it's very, very deep. So you can see what's happening. And here you have some extruded parts where we painted. So we need to make it 1 by default and only then black. So to simplify the math, I guess I will set it to 1 default, and then in the brush I will just invert this at the beginning, you know, to simplify the math, and invert it at the end. I know it's lame and cheating, but forgive me for that. It's to make the stream smoother. Okay, does it work now? I think so, because we're on the surface. Now let's try to paint. Yay! It does work. So where we paint, the parallax effect kicks in. Where we paint. But this is all in the shader. As you can see, the edge is sharp because it's just a shader trick. It's actually flat. Parallax occlusion is just a shader trick, but it already gives us lighting, which is amazing because this is what we needed. This is what was missing. Like this. Perfect. Jeffrey asks, why not change the reference plane on the parallax occlusion mapping? Because I believe the reference plane is just what is the flat surface, but not the direction. So it still would go upwards, I think. One learner asks, does it save into the material? It saves into the special kind of texture. When you do materials and textures, there is render target. I think you can't see that. It's outside the screen, but believe me, render target. And it's like a normal texture. You specify the size and the format, which is very important. Red 8 bits, and for this I used RGBA 32 bits float, so it also supports negative values. It's very heavy, but it was necessary. And yeah, and clear color is the default color. And then you create a material with which you paint into this texture every frame. This is my material. It's, as you can see, it takes the same texture as the input and it puts it on the output. And then the blueprint is drawing, not here. The blueprint begins drawing to render target, draws this material, and ends drawing to render target. This is quite more complicated here because we need to copy this texture first because you can't read and write at the same time. But if you go to techartade.com and go to products, you have Unreal Engine assets from YouTube tutorials. And there you can download the project files which contain the blueprint for that. Not the textures, because textures are from Epic, but the blueprint is there. Though you need Unreal Engine 5 for this example. Okay, so as you can see, just the normal map stays where it was. So we may need to also use the parallax UVs for it. Let's try. Piatnashkin says, now let's make a fluid simulations. Yay, I mean, sure. Because if you can read from the previous frame and write to this frame and read it again, you actually can do a solver. A solver that accumulates something over time. So fluids are perfectly possible. I have an example. I have an example on my shader toy. Where is it? Oh, here. Take a look. There's fluid simulation that I made. I don't know if you can see that. Okay, but anyway. You paint and the fire propagates. And it's a very simple effect based on the fact that it reads the previous frame, expands the fire and writes to the same texture. And it also vanishes over time, like so. So yeah, once again. You have the fuel. Oh, why it's dark? Again. Okay, blue is the fuel, black is no fuel, so walls. And it propagates. Like this. But it checks if the neighbor has fuel or not. If it's not, then it doesn't propagate. And this simple effect is just a render target, so buffer A. Yeah. So you can have a lot of fun with them, really. Okay, here we painted. Now let's try. Give me a small break to drink. And then let's try that, not that we will be painting, but a moving character will be painting. Basically deforming the snow behind. Let's make it look like a snow. Static mesh. Another texture. There was cobblestone something or concrete something. Yeah. But how to do tiling? I want tiling. Oh yeah, and we may try to combine that with some proper normal map. Snow, we have our own normal map. And let's do... So this would be like dynamic normal map. Okay. Let's have a standard normal map as well. So concrete N. Sorry. Tiled. Yeah. Parallax UVs. And blend angle corrected normals. Base normal will be this, and additional normal will be that. So use this node, blend angle corrected normals, to combine two normal maps. Okay, we have that. Very cool. Very cool. So let's drink some tea. And then let's try to make this guy move around. And then it will deform the snow. And if you have any questions, let me know. PlaneShift says, very nice. Thank you. I'm glad that you like it because I was quite anxious about the result. There were many problems with this. We started by trying to just use, shadows from Parallax Occlusion mapping and the Hive map, but it didn't look good. So we ended up with drawing normal map. Piatnashkin says awesome stuff as usual. Thank you very much. Great to hear that. I also admit I wasn't too prepared because I returned from vacations and wasn't in the right mindset for streaming yet. but it was a nice break. A Polish, how's it called? Voivodeship, a part of Poland where you have a lot of lakes. It's called Mazury. Basically forests and lakes. And this was super relaxing. Okay, so we have that. Now, let's try to make this one move. Do you know if there's some easy way of doing movement by path or by spline? Let's make a blueprint out of it. Or maybe I would just add a movement component. No, it's just rotating movement. Whatever. Spline. Okay, I will add. How to convert stuff to a blueprint? There was something like that, right? Converting to a blueprint. At least in Unreal Engine 4, there was. I just, oh, convert to static mesh. No, not to static mesh, to blueprint. I'll make a new one. Okay, so render targets. Blueprint class, actor, BP, render target, moving actor. Oh, thank you, plane shift. Let me take a look. Which YouTube.com. Spline mesh. Okay, weather is active. Okay, place the timeline. And then set actor location rotation. But where is it taken from? Spline, get spline length. Sure. Get location and distance along spline. Cool. Very cool. Thank you. So let's try that. There is scene root. Then let's add a component will be mesh component. Static mesh component? Oh no. Static mesh. Okay. Oh. And this will be my sphere. Great. Material, maybe this burning material, whatever. Okay. And then let's add the spline. Like this. Oh, come on. Spline. And let's add some points to the spline. There's a point. Great. Do you remember, guys, how to actually add points? Control click? No. Alt click? Nope. Or maybe just with Alt? Yeah. Dragging with Alt. Okay. Okay, great. We have that. Tangents can be set, awesome. And yeah, basic spline. Basic spline. Now in the event graph, on the event tick. Oh, Piatnashki says I can get a full transform. Great. So okay, spline. And now there should be some speed. So let's make it like a variable. Movement speed. It will be in a category settings. Instance editable. Float. I don't know. It will be like percent of the spline per second. So I don't know, like this. Percent 0.1 or no percent. Normalized length 0.1 of the spline per second. Cool. We have spline. We have speed. And there should be some accumulated time. Maybe I should just make a timer. So begin play. Timer. Because I'm not a fan of timelines, to be honest. Variables. Timer. Handle. Movement. Timer. Okay. Set timer by function name or by event? Event. Looping. No. Initial start. Looping, yes. Time. How long to wait? 0. Set timer by event. Movement timer. Set it here. And this event is what happens where it ends. So custom event. Restart movement. So where it happens, nothing should happen. Should just loop. Okay. And spline. It should take the movement timer, get elapsed time by handle. And this time should be multiplied by speed. But wait. The time is exactly 1, I think. No. Because it should be a module, right? So when it reaches, let's say, when it reaches, even if it's gonna take 10 seconds. Yeah, so not movement speed, but movement duration. And how long does it take to walk the full path in seconds? So let's say it takes the thing 5 seconds to move. And no movement duration here, 5 seconds. After 5 seconds it restarts. Movement timer. And this elapsed time should be divided by movement duration to know the normalized time. So from 0 to 1. Normalized time on spline. 0, 1 range. Okay. Normalized distance on spline, 0, 1 range. Now we have spline. Get transform add time. Does this have a duration, by the way? Duration 1. Awesome. Time, coordinate space world. Use constant velocity. I don't know. One learner, thanks for following. Use scale. Okay, and on every tick, so on every frame, we should check this full transform at the given time on this plane. So static mesh, set actor set location, set word location, this thing. Oh no, set word transform. No, wait, we shouldn't set transform. Or should we? Yeah, we should. Okay, so every frame, set the transform from what we read on this plane. Okay. It looks like this. Sweep. Yes. Let's see. I'm not sure what will happen. Did we place it? No. Moving actor. Okay, here it's spline. Yay! It moves. And rotates. It moves and rotates. It's quite too fast if you ask me. So, movement duration 10 seconds. And now, let's go back to our painting blueprint. And here we take position from the cursor. So let's duplicate this. Juanchito says, and yet it moves. Exactly. Exactly. That's what we ordered it to do, right? But it's surprising that it works the first time. Browse to asset. Snow displacement. Okay, it's already modified. So we can edit it freely. Here we are looking for the brush along the camera view direction. So we may delete that and not check if left, or we may check if left mouse is pressed, left mouse, or no, whatever. Draw cursor, no. Pass UVs to the material. But now the UVs, we have to find it from the point on the spline to the bottom. I think. Yeah. Okay, so the trace start will be... Wait a second, something's wrong. Okay, the trace start will be the actor. So first we have to find the actor. Get all actors of class. And the class is moving actor. Our own blueprint, right? We find it. We get 0. And we trace from the point slightly above our actor to the bottom. So get actor location. Where's location? Oh wait, we'll need to make more space. Okay, we're getting the location of the actor. We add a little on the top. We subtract, so minus 1000. And this will be trace start, trace end, to find the collision with the plane. To find, looking from above to find the collision on the UVs of the plane. Okay, so back to this. Oh, come on. And by the way, for those of you who don't know yet, on techart8.com you have most of the previous streams, actually almost all of them, as well as my other tutorials, like, procedural building, the classic one, optimization, how to make materials interactive. Most of the stuff is much easier than what we're doing today. So if you're interested, take a look. And in the products, you have blueprints from these streams and from other tutorials. I don't provide graphics for this example, this one, because, and for the recent ones from Twitch, because I'm using Epic textures. But from the older ones, from Unreal Engine 4, I also include textures and models. So that's about it. Let's try, wait a second, blueprint. Let's try. Well, no, it doesn't find anything. It doesn't find anything, but why? We can draw the trace. Persistent show trace. Stayed in the word permanently. This is risky. Ah, wait. Because we disconnected something. Okay. But I was also setting if should we draw. Yes, okay. Okay. It doesn't do much. Okay, it always tries to trace there. Ah, sorry. I know what I did. I should like this. I took the actor location. I should take the component location. So get static mesh, get component location. Yeah. See the difference? Component, not the actor. Let's try now. Okay, now it traces in the correct place. But I think it collides with itself. Okay. So let's open this again. This thing. This is movable. That's good. Collision preset. Block all dynamic. No collision. Can character step? No. And then in the event graph of this tracing, line trace by component. But it should, it would be ideal if it ignored other stuff. I don't know if it will work or not. It tries to trace and I think it hits it because, as you can see, yeah, it should return the hit. So what's wrong? Trace start, trace end. Find collision UVs. Set parameter. Draw. Everything is there. Brush position is here. Render target is here. Now I wonder if this has to be invisible or something. Rendering. Visible? Not. Let's see. Okay, now the line moves, but it doesn't draw. That's bad. Visible again. Now let's go back to this. Uh-oh. The boolean is not here. There shouldn't be any and. Just if it found collision or not. Okay. No. Yay. You can see it beautifully displacing the snow. It's way too strong, of course. Let's change the flow. Brush material. There was flow 002. Let's do this divided by 3. Okay. Yeah. You can see how it tries to how it displaces, and then it makes it even deeper than it was. Then a jump. Yeah. How do you like it, guys and girls? What do you think? Of course, much more can be done here. This reference plane that Jeffrey mentioned, the setting in the Parallax Occlusion Mapping node, that it shouldn't start at 0. It should start, you know, there should be some space for the accumulating snow on the edges. So deep on the middle, but slightly bumped on the edges. That's one improvement you could try to make. And of course, some splatting of some random snow around could be cool as well. Not just a uniform circle. Piatnashkin will add NPCs to their sidewalk vandalism simulator. Now take a look. If I play that, it moves here. Now I press F8, select it, and move. Can you see what happens? It still works because the texture is persistent actually. Okay, we have it. We have our snow. One learner says the deeper it goes, the more the texture stretches. Yes, because you can see the artifact here. Because how it works, how parallax occlusion mapping works, is it's taking some samples along a ray, and here, of course, the number of samples is limited. But so if this is very steep, or very deep, then we have problems. So you will have to maintain the maximum height at something reasonable. But I will show you this relevant setting. This is in the snow material. In the parallax occlusion mapping node, there is min steps and max steps. It's 32 by default, so this is already pretty big. And you know, 32 samples of a texture is a lot in a real-time context. So it would be better to just limit the number of these. Oh yeah. So thank you very much for being here. Let me take a look on Twitch. if there's someone I can raid. Raid. No, just Sumi, my friend, playing Skyrim. Okay, so see you next Wednesday at the same time. So 7 p.m. BST. Cheers.